Water gives like a temporary reprieve, but it does come back hot. We're talking about use cases, so.
Hey everybody, my name is Will. I am head of community at Mina Foundation, and I'm here with Evan, Mina's co-founder. Evan founded Mina back in 2017. Mina is first ZK native layer 1 blockchain for ZK rollup in production. We also call it the Mina proof of everything. Our proof layer is called Kimchi, which is inspired by the recursion layer called Pickles. We're going to start with the less spicy ones, I think.
Yeah.
And then as we progress, our friends here have also brought us some nice, very spicy wing sauce. Evan, welcome to the show. How do you like kimchi?
This is a cool experiment, I guess, that we are doing. I really do like kimchi a lot. I'm not sure how to feel about the one that we put the extra hot sauce on, but otherwise I love kimchi, so I'm excited to try all these different ones.
Let's get into it. This is the least spicy one, so we're just getting involved.
Where's this one from?
7-Eleven, I think.
Nice.
Very nice. We were talking yesterday a little bit about the history of Mina and some of the inspiration around getting started. If I remember correctly, you started Mina was your first project outside of school. Is that correct?
I was actually a friend from high school. So we'd known each other for already a bunch of years at that point. This was 2017, so I was 24 and Izzy was also, but I guess we know each other for almost 8-9 years at that point. I was living in the Bay Area. I had just decided not to do a PhD. Izzy had just come out to the Bay Area to do a PhD in cryptography. We started spending time together and talking about projects and things we were interested in, and different things we could work on together as projects, just because that'd be fun to do. It was in high school, we were both kind of just talking a lot about technology and math and kind of philosophy-ish stuff like you do in high school. We didn't actually get any crypto, but we knew that it was a thing. We were following it. We thought it was cool. We were following all the altcoins coming up after Bitcoin as well. So one of the things Izzy doing in cryptography, and we spent a lot of time talking about it, was where was this cryptocurrency thing that we've been following for so long? We've been following crypto now for since 2011 or so. So 6 years. Where was it? People were definitely more excited about it when we first was there. It had the momentum, but there was this big disconnect between how people had been talking about the technology and still were talking about it, and where the technology actually was. Everyone was oh yeah, this is going to be the future of digital payments. People were starting to talk about this being a place for computation as well, and very exciting. And you actually look at the technology and it's oh man, no, this is not going to happen. If you look at it as we're doing really 3.5 transactions per second on Bitcoin, and already there's this huge argument about whether the chain's growing too large or not too quickly. And it would be cool if this was something everyone could use, but it's totally not going to happen.
Right.
So we started thinking about what would it look like to build a cryptocurrency that had the technical properties to get out to a large number of people. And that eventually brought us to zero knowledge proofs.
And where was the state of research around zero knowledge proofs at that time?
Yeah, it was very, very different than it is now. There had been a good bit of research coming out of kind of the late 2000s and also the early 2010s that were making zero knowledge proofs not just theoretically viable, but practically viable as well. It was suddenly possible that you could do a very large computation, and it wasn't that fast, but you could do it at all, and the proofs were very small, and it could be done in a matter of minutes.
And were those experiments not just in relation to blockchain, but also just computation in general?
Yeah, I mean, I think this was it came out of cryptography as a research field. It wasn't cryptocurrency.
Right.
Yeah, I mean, there were, I think, 3 projects around the time we were doing. There was Zcash, who was earlier than us, Starkware, who had started around the same time, maybe just before, and then there was us. And there were maybe literally 20, 30 people in the world that understood and knew how to use the new set of efficient zero knowledge proof technology coming out.
Right.
And it was just kind of we knew who everyone was. Izzy was one of them.
Right.
And we knew enough about the technology. Well, Izzy knew a lot about it to be able to start thinking about applying it.
Right. That's fantastic. How was the spice level on the first?
Like 2 out of 10.
2 out of 10?
2 out of 10.
Okay.
In Pittsburgh, where, like they have this thing where all the restaurants, you could order by spicy level 1 through 10. And all the restaurants were like relatively consistent. It was really
Really?
cool. Yeah.
For like Mexican food or any specific
anything, like all the restaurants. It was awesome. Yeah. So this was like a 1. This is like a 2 out of 10 on the that scale.
I think we're moving into our second one here.
Pretty good. It's different than the first one.
In those early days, I'm sure there was, given how those 3 projects have all ended up working on different problems and solutions, what was the relationship between like the technical design decisions and the vision of where you saw Mina?
There's 2 parts of it. There was the research problem at the time, which was just, can we build a chain which is efficient to verify if a large number of people are using it? And that was like kind of like with ZK snarks, you have this one little proof that verifies everything. Great. So that's like a more complicated when you actually do it, but at least in principle, it solves the problem. There's the other part of it, which was like, okay, like the other thing that's happening with crypto at the time was computation and being able to put actual computer programs on chain. We were thinking about and talking about what would it look like for zero knowledge proofs to be able to do that. It wasn't quite ready yet at the time. So we had like, sketches of little like, virtual CPUs you could build in a circuit and stuff. But now we're at the stage where like that stuff's like very ready and you can launch it, which is really cool. It was really both of those. And we were like, okay, like let's build this chain first that like is like ZK based and can like leverage all that natively. Yeah. And we were always thinking about, we'll add computation on afterwards.
In a way, kind of like looking back at the problem of what you were seeing around the vision for what Bitcoin could be, but then the reality of anyone who wants to access it has to download the entire ledger, has to basically be able to verify it themselves. But there's only one way to verify it, which is syncing a node, which requires all these other things. And were you thinking about a layer 1 at that stage?
For sure. Yeah. There were times we thought about what it'd be like to like, like fork Bitcoin. Yeah. Like, and just like have like a, mini Bitcoin. The plan was always to do a layer 1. We were excited about doing a layer 1.
I think it shows up in the like design decisions that of where Mina is today, how it is so fundamentally different from the ground up. And it kind of flips when a lot of developers come into Mina's community for the first time. It takes a little bit of learning to understand the different mental model that's required, not only to build stuff on top, but even to thinking about how the chain is composed and how it is a proof in itself.
It's just very different. It's built to be able to have these properties.
Can you talk a little bit about like why those properties are important in terms of scalability long term?
You have this like, object, like this blockchain that like exists out there, and you interact with it as a user. But what does it mean to interact with it as a user? A lot of the times we interact with blockchains today, you're actually, you're going through a centralized exchange. They're talking to the blockchain. You're going through like a wallet that's talking to like a centralized provider. Each time you do that, you're accessing the blockchain, but indirectly, there's someone else you're kind of trusting to be able to get that access. Maybe that's okay, but I think like there's this vision of what it would be like to create this world where you can directly access this centralized technology, and it is kind of based on what we all kind of want to see. And it doesn't have all these like middlemen and guardians that like are seeing opportunities to extract value from the system and are like kind of otherwise deciding and regulating what it looks like in a way that like kind of like is less based on what people might want.
Yes.
And so like there's like this possibility of this direct access from users that is possible, and that was like what we were trying to do. And there's also this reality of it where like it's not just like binary whether you can access it or not. It's Bitcoin's usage, like maybe it's good enough. Like, if you really want to, you can download the chain. There's enough people, there's a good bit of people doing that. We probably can't do it as an individual at this point anymore, like easily, but if you're like a serious, developer or whatever, you can do it. But if you look at like what it looks like to build some of these chains that are much larger and can do much higher throughput, then you're looking at a world where like, really as individuals, you can't even access it anymore. Even if you are like kind of on the developer side, like you're probably at that point like looking at a world where only a handful of like companies are running it. And I mean, I think like a good example of this, like EOS tried this, I think. And like, like it's kind of cool they actually like did it, but you can kind of see like it ended up with like this very small number of centralized block producers who handled like this huge amount of data that was flying through this thing and storing it. Eventually at some point you're not, you lose a good bit of decentralization. Unfortunately.
And now, I mean, I think one of the key innovations is the idea for anyone to be able, like in the completely permissionless network, how do you define permissionless? I think we use that word a lot, but it's not necessarily, well, I don't have a clear definition in my head, but one of the ways that I think about it is, can anyone have access to it? Can anyone write to it?
In a good way, I think is like what dependencies are there? Who are you relying upon to access this chain?
Yeah.
If you're relying on like, an RPC node somewhere that's sending data to your MetaMask, like, you're accessing it through them.
Right.
And, it's not fully, I would say, permissionless.
What I see a lot of developers really get inspired by coming in and working directly with Mina is it's not theoretical anymore. It's actually possible that you can access the chain directly. Anyone can verify with from the browser. It's just a proof point that it's a real thing.
Yes.
It's not theoretical.
I thought 2 was like kind of the same as 1. Like
similar,
a little bit less spicy.
Which is good. We got a lot of talking points out there.
We'll see if 3 and 5 are spicy. The one we put the thing on that one, I'm concerned about.
0 to 100.
They're also different. Really cool. This one's like citrusy.
It's got a little bit of a kick.
4 out of 10 on the, maybe 5.
I mean, it's growing a little bit. We'll see.
5 out of 10.
For those following along
Pittsburgh scale.
on the official Pittsburgh registry, which now I think is a good standard that we can talk about. Yeah, 5, 4.
I think it's a 5.
Yeah. Okay. Let's talk about the move to programmability. Maybe you can give a little bit of context on where we are now.
I mean, just connecting it together, like there were all these iterations we were thinking about for how to build a programmable smart contract system that used ZK. There were really I think 2 things that kind of made it all make sense. One was recursive verification of zero knowledge proofs, where also like the ability, you could dynamically write new zero knowledge proofs and then verify them inside of main zero knowledge proof. So you can write a program, becomes a zero knowledge proof, you can verify it. So you can dynamically do these. You don't have to statically declare all these. That's great. You can all these little programs, verify them all. And any developer can write anything. And the other thing was the ability to not have a trusted setup. That was very good, for one that that technology came along so that we didn't have to do that for the mainnet launch. But also so that all these new programs don't need their own trusted setup. So you can write a program, doesn't need a trusted setup, you just deploy it. There's a lot of other things about the architecture, but those are really the things that unlocked it and made it so that you could really have the ability to write any zero knowledge proof program you want, and then interact with it from one chain.
Yesterday we were talking a little bit in detail around recursion and the kind of implications of rolling proofs into other proofs, and I think you used the word composability, which gets thrown a lot in this current space, but maybe if you can talk a little bit about the benefit there.
I mean, oftentimes just it's more powerful when you have all these different, possibilities of combining things and putting them together. You can take a proof of location and a proof of nationality and a proof of your blockchain activity. You can suddenly take all these things and put them together. That's really useful when you're building an application. Especially because you can compose all these different private data sources together.
Yes.
You can have a voting platform where you have private voting, but you could have a source of that be, some proof about you being a single person and not a bunch of people, for example. And you can combine those together into one proof at the end that has all the information relevant necessary for that. So it just makes things a lot more elegant and easy to work with, which is ends up, I think, making it easier as a developer to build more powerful things, makes it better as a user to start using applications that were easier to construct and have all these complicated things they can do. I think it's really kind of on the developer side, but it's a useful kind of thing to have available.
Yes.
It's a very different building system where it's this little part and this little part, I'm going to connect them together and in this kind of manual, fiddly ways versus everything just kind of composes together.
Yes.
So when I'm writing all these zero knowledge proof stuff, it is just kind of just very easy from a complexity perspective when you're writing it. So I think you kind of got to start writing a lot of zero knowledge proofs to kind of see what the deal is. But I think you'll see if you use systems with composability, like Mina, which I think is maybe one of, not the only one right now that has that, you'll find it a lot easier to build your programs.
Yes.
You'll see also opportunities for things that you may not have thought about before. Be because I can compose things in this way, it's way easier.
One interesting moment as well is as we approach to bringing zero knowledge applications onto mainnet, we're also really dramatically in production, reducing the costs, what it costs to write a zero knowledge circuit. If you're a developer coming in and previously you have to learn CIRCOM, or you have to really like be an expert and go through all of these steps, not only learning, but then also in terms of proving time and the costs that are related with that as well. We're really dramatically lowering that cost. And so it's kind of this watershed moment of, we don't know what people are going to build explicitly, but we do know there's a lot of people who are building the building blocks all over, and it's increasing rapidly. So I think once we see these different pieces come together as well, it will help paint that composability picture more. I think it would be really interesting to talk a little bit about use cases. And we've been building a lot of things on testnet, and there's a lot of people who are interested in specific niche ideas. But I'd be curious to hear it from you with the full context of the vision. Like, what are some of the use cases that you're interested in, and where do we have to go to, what are the building blocks that are left to make those a reality?
Yeah, totally.
Should we start with the bomb and then talk through it in pain?
Okay, sure. Let's do it.
Okay, so before we get into it,
see if I'm
Beyond Insanity.
Yeah, this is the one that it's
Pittsburgh level 100.
This will be spicy, I think. This will not be a 5.
And my question is asked, so I think once we go, it's just up to you to answer.
And I believe there's 2 drops of that.
There's 2 drops.
Great.
All right. Cheers.
Cheers. Oh man, that's pretty spicy.
Okay, so
no. Oh.
Yeah.
It was pretty spicy, but no, it's pretty spicy. I think this is like a 9.5. They do, if you ask for 10, I'm getting hiccups. That happens when I have
that happens to me too.
Really
I get the heat
spicy.
hiccups. I'm like 2.
Yeah. This is, maybe it's a 10. It's a 9.5. I know they
maybe it will build into it
stuff, but this is pretty spicy.
Don't touch your eyes, apparently.
I don't know.
Okay, so use cases.
Water gives like a temporary reprieve, but
then it comes back a bit hotter, actually.
Oh, it does come back hot. Use cases. We're talking about use cases, so right. So there's a lot already going to be possible, and a lot of teams that are launching things, which is really cool. I think that there's some building blocks that still need to be in place and that are happening, which are fungible tokens, very key, important for crypto ecosystem. Building DeFi, very important, like primitive for the whole thing. That coming out, very important. I think NFTs also are a thing that needs to come out. One thing I find really interesting is like crypto so far. I think a lot of these cases have been fungible tokens or NFTs. It's like kind of coming back. It's like the last press attack. Okay, let's do this. Yeah. So fungible tokens, NFTs have been kind of key building blocks that have enabled a lot of use cases for their chains. I think that what's cool is like with Mina, we can have other use cases beyond those powered by zero knowledge groups around privacy, around verifiability. And so there's other building blocks we need beyond like an ERC20 equivalent and an ERC721 equivalent. We need also have a building block around data that is kept private on users' devices, and then they make proofs and they send that out to the chain. And so we have this cool like kind of third building block that I think we will enable a lot of things to happen. So I think once the hard fork's out, there's already gonna be a lot of stuff that gets released that like is really powerful. Things like private voting, layer 2s, privacy pools that are like compliant, like from regulation perspective, like private scientific applications. Like a lot of stuff that gets enabled. But I think like the next step, hard fork, we build these like these kind of like key like APIs or standards or whatever, and then on top of those, we can start building a lot of applications that start using those.
The rest of kind of the crypto world thinks about fungible, non-fungible standards, but we also are thinking about a separate category of standards that is taking a data set that can be recognized from anywhere, where a user can potentially take their wallet, extract data from this source that's specific to them. And the standard, I think we've been talking a lot about the passport RFC, or the passport standard.
ZK passport would be an example.
The standard in itself would be the passport standard all around the world that's used to issue, I guess, like government issued passports from a list of countries. And then the wallet takes the data from the standard and creates proofs from it that are unique to you.
Exactly. The sensitive, like personal data doesn't leave like your like wallet or your like, safe, box, right?
Yes.
But the proofs leave.
Yes.
And the proofs don't expose the information about the underlying data, but you can use the proofs to interact with applications.
Yes.
For example, saying like, this is an application where, we're going to give an NFT to like each person.
Yeah.
But each person, can only get one NFT because of these underlying proofs of like having a unique passport.
Yeah.
For example.
It gets really interesting as well when we go back to the open source community aspect of anyone's able to then come in and easily write ZK apps that consume data from any standard, any accepted standards, and the standards themselves will find a way to like them. I think there'll be many different accepted ways of collecting data, and it can be anything to a very specific use case. Like we're seeing some people in the healthcare world building off of specific data that's used to transfer between institutions, or something like passport, or something even much more narrow than that.
And this is also where there's a lot of like people that are already building these like little proofs of things, but once there's like a standard, people can make those all composable with each other. So you can have like you have your wallet and you're collecting these like credentials as you go around the internet. And you go to another web page, and the web page asks like, I want a proof of like this and this and this and this, and you can deliver them like a proof composed of the underlying credentials.
Yes,
it's going to be cool when we have the Mina to build this stuff.
Yeah. How are you feeling?
I'm okay actually. Where it's like coming down from the spiciness. It was survivable. So that's good.
Yeah, the hiccups pass.
The hiccups have passed.
Yeah, I'm glad you get it too, because sometimes the worst is when you're eating a meal and then you start hiccuping and then you just you lose your Yeah.
I would usually get like a 7 or an 8 in Pittsburgh. So this is
okay.
I think I can still enjoy the last one though. So.
Speaking of standards,
also really different.
Oh, I dropped it in. I dropped it into bomb. All right. I hope I didn't get any left over to bomb.
Normal again.
Nice.
Normal kimchi. Not.
Yeah, we're okay. I think there's one other aspect which I get really interested about, which is at the end you mentioned the website checks the proof.
Yeah.
It extracts whatever information it needs, but again, it's not collecting any data. But something we haven't really seen yet, because it's a little bit of a cold start in that you need the ZK app libraries and you need the kind of like integrations into apps in general before websites can interact with them. But my understanding is it's a much easier interaction for like websites or web applications that don't have to build a native Web3 application to use this information. Instead, they can just call the Mina network and interact with it in that way, which is, I think, is much easier than what it will take to do if you want to build it yourself.
Ideally, like it should be pretty easy for a website to integrate some of this stuff and start accepting proofs and producing data that can be used for other proofs. And I think that like that becomes possible.
The API is the proof. An
API for like efficient verification of like Web3 and Web2 data, and an API for like private proofs of user data. Those mean like very useful for like kind of bridging Web3 and Web2.
One of the main critiques of Web3 in general is like, well, you can tie a lot of these systems directly together with, Web2 systems directly with just a web of APIs, and why not just do it that way if Web3 isn't permissionless in the way that we think about it. But if we tie back to where the original design implications is, anyone should be able to verify.
Exactly. No, I mean, it perfectly connects back to like some of the original things we were trying to do with Mina, just like extended now with like all this programmable stuff that like lets it be more powerfully integrated into the web.
Yes.
And I don't think we originally like kind of were thinking about like, okay, it's like a blockchain, it's like an object, it lets you like, use all the stuff that get access to new technology, but integrating it deeply with the web is totally like a getting it out to the world is it's a good thing for that.
Yeah, absolutely. Proof of everything.
Yeah. Yeah.